Hello everyone. Today we're going to walk through one of the most common hybrid AWS architectures found in industry, and this is something that is going to happen somewhat frequently if you plan on becoming an architect or something like that, where you'll be discussing with clients who may have cloud native or legacy workloads and so on. So it's basically your responsibility then to find a way where you can have these two systems synergize and work in a fluent manner, essentially. The structure of this video is going to be fairly simple. The first portion of the video will be very briefly just going over the architecture that we found and and basically talk about why it works, why you'd find this in industry, and the merits of using something like this. And then the second half of the video, we're going to talk about how we can improve this already existing architecture for uh, a variety of different reasons. Usually, the improvements of a architecture like this will be based from client to client. Some clients will not really care too much about cost. They only care about the maximum level of performance they can get. Meanwhile, other clients, they want to be able to save as much money as possible. So from cost optimization to resiliency to high availability, um, is for any of these reasons you may want to optimize further an existing architecture. So that's something to keep in mind. So this is the architecture that we're going to be looking at. Let's start off with the AWS side. So on the left side here, um, content delivery. We've got, as you can see, it's fronted by Amazon CloudFront, um, which is backed by S3 for static assets and API Gateway for microservices. Um, the security, as you can see near the top, it's layered with AWS WAF and Shield to handle things like, or handle threats like DDoS attacks. um, the thing about CloudFront is that it doesn't just boost performance by caching assets closer to users, it acts as a shield. So, for example, when CloudFront is in front of your APIs, bad traffic can be filtered at the edge before it even reaches your origin. This is huge because this massively reduces unnecessary compute costs and improves your app's survivability during large-scale bot attacks or spikes. As you can see as well near the core, we've got Amazon ECS Fargate running containerized services. This is great because, as we discussed in the previous video, serverless means there's no infrastructure to manage. It's great. Um, these containers, the ECS containers, they connect directly to RDS for relational data and Elasticache for speed. Um, a little bonus tip: Elasticache isn't just about performance; it also lowers the load on your RDS database. Um, every cache hit means one less database query, which not only reduces RDS cost but also makes your architecture more resilient to traffic surges or API abuse and so on. Um, this is kind of where you can probably use things like SNS for decoupled messaging. So this will like notify systems when something changes. Uh, Decoupling with SNS is great for things like fault tolerance. If one downstream service is unavailable, SNS can still accept and queue the message. So you're no longer tightly coupled to one service's like uptime. It's a simple way to boost things like resilience without a full-blown event bus. Um, Moving on to like the security and the network layer, to to bridge the cloud and the on-premise data center, as you can see on the right. To bridge this, we've got a site-to-site VPN via the virtual private gateway on AWS, and a customer gateway on-premise. So this keeps the traffic secure and private. One, this is very important. One often overlooked benefit of this VPN setup is that it supports is support for BGP, otherwise known as Border Gateway Protocol. So this allows dynamic routing updates, which means you can change IP ranges in your on-premise network without constantly updating route tables manually on AWS. So that's just something that is usually forgotten, but it's very interesting. If you ever need that functionality, it's there with a setup like this. Um, on the right, we've got so let's move on to the right side now. So on the right, we've got regulated workloads. So these are usually legacy systems, or like compliance sensitive databases, or internal APIs. All of that is managed through an on-premise API gateway, with obviously ECS running in virtual machines or bare metal servers and so on. Um, running running ECS like orchestration on premise is more than just tech mirroring. It eases future migrations. So that's something you want to really think about, because normally when people have a setup like this, a hybrid setup, either they're new to the cloud or they are still in the transitioning phase. But yeah, going back to ECS like orchestration, if your workloads already follow container patterns, it's much simpler to migrate them to AWS in phases. So essentially, you're building a cloud native discipline inside your data center. So yeah, and at the top, um, you see Route 53. So this helps direct traffic or unregulated API calls go to AWS CloudFront and API gateway. Meanwhile, sensitive regulated calls get routed back to the data center. A little bonus tip, Route 53, is that we all know it supports things like geolocation and latency-based routing, so you could, in theory, configure it to send EU users to GDPR compliance services in region, or automatically route users to the lowest latency endpoint for global apps. So this is kind of a really smart way to balance compliance and speed and user experience. So overall, why is this setup good? This setup, again, is a very standard setup you'd see in industry. This setup is robust, it scales well on the cloud side, and keeps regulated data secure and compliant. And the customer gets the best of both worlds: modern cloud agility plus on-premise control. Um, Hybrid architectures aren't just a stopgap, they're a strategic layer for enterprises with sunk costs in data centers. But that doesn't mean stagnation. So hybrid setups like this let you modernize in slices. Think of it as agile infrastructure migration, something like that. So yes, now we can now optimize this further. If we move on, so this we're going to enter the second part of this video now, where we're going to optimize this a little bit further. So now let's first of all take a look at EC2 versus EC2's spot instances versus ECS Fargate. So we've already talked a lot about Fargate in the previous video and a little bit in this video already. So as we already know, ECS Fargate is fantastic for reducing operation overhead, but it comes at a premium. For steady state predictable workloads, switching to ECS on EC2 with spot instances um, it can come up to about 70% savings, or at least use saving plans. Um, Spot instances are like most effective when they're paired with capacity aware or autoscaling groups like lifecycle hooks. So your workloads can gracefully shut down and reallocate without losing state. So this transforms a cost saving tool into a fault tolerant compute layer. So that's something to keep in mind. Um, Moving on from this, we've got VPN versus direct connect. So VPN is secure, but for high throughput workloads between AWS and on-premise, direct connect offers more reliable performance and lower data transfer costs. Direct connect also gives you deterministic latency, which is crucial when synchronizing two database systems or real-time applications. It's like replacing a dodgy back alley with a dedicated fiber highway. It's so that's one of the things Direct Connect has over VPN, which we could potentially use in this instance. Next, we have RDS optimization. So, when it comes to RDS optimization, the first question we need to ask is: are we using provisioned capacity, um, and or are we over provisioning? We can likely save, I would say, between 20 to 40% by switching to something like Aurora Serverless v2, or at least right-sizing the instance types and enabling autoscaling. Um, Aurora Serverless V2, it shines. Sorry, one second. It shines in unpredictable workloads because it can scale in fractions of ACUs, otherwise known as Aurora capacity units. If any of you are studying for the exam, that's something to keep out for. It's a question that can come up. ACUs are subjective. It's strictly for Aurora. But yeah, so this means you don't pay for large jumps in CPU or memory. So this gives you cloud elasticity and cost granularity. So it's very, very strong. Moving on to CloudFront and S3. So S3 is great. It's fantastic because it's cheap, but we can make it even cheaper. So all we need to ask ourselves is, are all static assets being stored in the right S3 storage class? We can move infrequently accessed objects to intelligent tiering or S3 Glacier, which could cut costs dramatically. We want to minimize that idle accumulation of cost, right? So this is something that not a lot of people realize, is that intelligent tiering in S3, it uses machine learning to predict access patterns. So it auto tunes transitions files between frequent and infrequent tiers without you doing a thing. It's like having a invisible site reliability engineer optimizing your storage 24/7. It's very powerful. It's very strong. Um, Moving a little bit on to API gateway pricing. So API gateway is another sneaky cost sink. It's you wouldn't imagine this really would pick up much of a cost at the end of the month, but it can. If the traffic is high and predictable, we can consider switching from a per request pricing to HTTP APIs, which can be up to 70% cheaper than using REST APIs. HTTP APIs also supports things like JWT authorization natively, so you can offload auth logic to a service like Amazon Cognito or a custom identity provider. So this not only saves cost but reduces cold start auth logic inside Lambda or your backend APIs. Now, let's move on to monitoring. So with monitoring, what we're trying to do is look at idle resource elimination. So we don't want to rack up costs by just things running idly. So we can also set up in this instance a CloudWatch alarms and things like AWS Trusted Advisor to identify idle resources like unattached EBS volumes or things like underutilized instances or even things like zombie containers, all of which quietly burn cache. Um, I would say use CloudWatch anomaly detection instead of fixed thresholds. It learns what normal quotation marks looks like and flags when usage drifts unexpectedly. This is especially useful for catching creeping cost leaks or sudden misconfigurations. So something to keep in mind. Now, the hybrid evolution strategy. So we want to think long term. Are these on-premise workloads truly required, or are we holding on to legacy out of habit? So over time, we can look at refactoring service into Lambda, containerizing more apps, or migrating databases to Aurora or DynamoDB. a good um, a good stepping stone is, if you've heard of it, the strangler fig pattern, where new functionality is built in the cloud while legacy systems are gradually phased out. This avoids risky forklift migrations and lets you prove value incrementally. So yes, that's nice little food for thought right there. So yeah, so let's wrap this up. So this is how you would take a strong, already existing hybrid architecture and make it leaner, smarter, and cheaper. Remember, cloud isn't just about moving your workloads; it's about evolving how you think about infrastructure. So that's something to keep in mind. Uh, and yeah, so let me know in the comments which part of the setup you would optimize first, or what your favorite optimization strategies are. There's a lot of different ways you can optimize an existing architecture. We just did a little general overview covering a few things like cost optimization and some resiliency. But yeah, thank you for sticking around.